So my name is Frank, and I'm here to talk to you about overlay images, also known as extension images and capsule images. I see Chuck right there in front of me. So I have a book. It's brand new. So it was released on May 27th, so less than a month old, and it covers Linux 6.6 and Yocto 5.0 Scarf Gap. So that is the latest Yocto LTS and a relatively new LTS kernel. And I will have 3 copies of the book to give out to those who stick around. I guess there's quite a lot of you, so you can't all have a book, but we'll work something out. Okay, so this is the agenda for my talk. I'm going to explain what an immutable Linux distro is and where they're being used. And then I'm going to talk about extension images, which are the overlay images in the title. I'm not going to say overlay images from here on out. And then I'm going to show you some use cases for extension images, like an SSHD, like an SSH server, a native GDB debugging on the target, as well as remote GDB off target, eBPF, bpftrace in particular, so that's used for observability, and VPN. In my case, my favorite VPN, which is Tailscale. So let's start with the Steam Deck, the big embedded Linux success story. 4 million Steam Decks sold since the February 25th, 22 release. So this invented the product category of PC handhelds. So, you know, in 2022, they had all the market share of PC handhelds because they were the only one. At this stage, they have less than 50%. So there are copycats, but they still have a big chunk of the market. I think 48% last I checked. The Steam Deck is running Arch Linux. It's not running Windows, which is cool because that means PCs doesn't mean Windows. It also means Linux now. There are Linux PCs. Now let's contrast this with the Nintendo Switch, which is not running Linux. There have been over 150 million Nintendo Switches sold in 8 years. Switch 2 just came out June 6. 3 million were sold on release date. So a lot of pent-up demand for the Switch 2. And Switch 2 is on track to exceed expectations in sales. So, you know, these are not opinions, they're just data points. Draw your own conclusions. Okay, AB updates. So both the Steam Deck, which is running SteamOS, and most Android devices are using AB updates to update the operating system. So this is kind of the experience you're used to with mobile devices, where you get a new version of the operating system installed. I'm not going to get into the details of how AB updates work. If you have a background in embedded Linux, you know how they work. I found out that SteamOS is doing A/B updates from this blog post by Ileana, I'm going to butcher her last name. Your guess is as good as mine. Itauen, apologies, Ileana. So her blog post was how I forked SteamOS for my living room PC. So this is how I found out that the Steam Deck is running Arch and is doing A/B updates. So it is an immutable Linux distro. I mean, Arch typically is not, but they've turned it into an immutable Linux distro. You know, Valve has for the Steam Deck. And the way they're doing A/B updates is using Rauk, which is a popular A/B update mechanism in the embedded Linux world. And they are, for the parts that are mutable, like the writable parts of the root file system, they're using btrfs, which is pretty cool, because if you know anything about btrfs, it has advanced features like subvolumes and snapshots. So that's impressive. So Arch is not an immutable distro. What is an immutable Linux distro? So immutable means read-only. That's what immutable means. So the majority of the root file system is read-only. You can't write to it. Only the var directory is writable, and so that it's mounted on its own dedicated partition that's writable. All system changes, app installations, happen in a layered or sandboxed environment. Containers, Flatpak, that kind of thing. So I wanted to kick the tires on one of these, because I don't have a Steam Deck, so I don't have the immutable distro experience. So what I did is I wiped my mini PC and I installed Project Bluefin on it. So that is an immutable Linux distro. And that was like maybe a few weeks ago that I did this. And I have to say the experience has been great so far. I've been able to do everything I want, which is like Yocto development on an immutable Linux distro. If any of you out there have framework laptops, hands, okay, that's some. So the framework 13 fully supports Bluefin. So it's like they support Arch as well, but they tell you if you want the easy path, the easiest out-of-box experience with a framework 13, install Bluefin on it. Capsule images. There's no clock in here. Okay. When does this end? I want to make sure I don't run out of time. Okay, so this is Chuck's idea. So I did not come up with this idea. I learned about it at the Yocto Project Summit back in December. So not that long ago. And so his first slide was like, do one thing. Like that's it. And that's pretty much all the explanation. It's like you have an image and it just does one thing. And in his example, that one thing was SSHD. So he had a capsule image that it only had the configuration files and the binaries for SSHD and nothing else. That was the capsule image. And so the genesis for this was actually the Yocto mailing list. So I looked at this. So someone had asked if there was a way to install packages onto an image without pulling in any of the dependencies. And Chuck responded, yeah, there is, and this is how you do it. And so here's an example of the bitbake that does this. So he's installing the OpenSSH, the SSHD package, the binaries for SSHD. And then there are other binaries that SSHD requires, like there's like a keygen. So this isn't all of it, but what he's not doing is he's not doing rdepends and pulling in all the runtime dependencies. The expectation is that those are already on the base image. That's the whole concept of a capsule image, is just give me the thing without its dependencies. All right, extension images. So this is the topic. So this extension images are a systemd feature that were introduced in systemd 248 back in March 2021, so fairly mature at this point. And the way extension images work are you install squashfs raw files into varlib extensions and varlib configs. So these are the writable, it's var, so this is the writable part of your distro. And what happens on startup is that systemd will look at the contents of those directories, scan them for system extensions and conf extensions, and then compose them on top of the root file system. So it will merge the user and op directories for the system extensions, and it will merge the contents of the etc directory from the conf extensions. And so, this has been around for a while, and some distros have adopted it and are using it. So the flat car container Linux, which this is a cloud operating system. I understand that that's a thing in Azure. I believe Microsoft is sponsoring flat car container Linux. So it's a thing in the cloud. And then there's also Particle OS, which is systemd's own distro that they're building just for Leonard, because Leonard wants an image-based OS like the Steam Deck. All right, so at this point, some smart aleck is thinking to themselves, why didn't you just use containers? That smart aleck is usually me. All right. So I say to you, think outside the box. Everybody uses containers. Your boss wants you to use containers because all the other managers are using containers. Just why not try something else? It's like Jim Keller says, like when NVIDIA goes one way, I go the other way. So dare to be different. Now, the thing about capsule images and extension images is we have this wonderful build system, right? Yocto. The whole purpose of Yocto is to build images, right? You're building your own Linux distro. We were made to do this. That's all we do is build images in Yocto. We have image recipe files, I just showed you the one that Chuck did for SSHD. So, usually you're building the whole shebang, but there's no reason you could just build what you want as an extension image. And then lastly, systemd is great, stop fighting it. Just, they're winning. Just go for it. Okay, so how do I work this extension image stuff? I wanted to find out, like, how do you do it? Another blog post, this time Alberto Garcia. Adding software to the Steam Deck with systemd-sysext. So Steam Deck, like, it doesn't default to extension images. They want you to use Flatpak. I'm assume that's how the games are packaged, as Flatpak. I don't really know. I don't have a Steam Deck, but Steam Deck advocates, it pushes you towards Flatpak. That's fine. But sysext offers you an alternative to Flatpak if you don't want to do Flatpak. And so that's what Alberto did. So here's an example of how you do it, well, how Alberto did it. So he downloaded this drop-down terminal emulator, and he downloaded the binary package, so not the source code. He's not building the source code. He's downloading pre-built binaries. And so then he extracts those binaries into a user directory, and so this is like a fake root, So you extract it into the user directory, and one thing I really like that he said is that extensions are not distribution packages, which I think is really critical to understand. Is like, unlike RPMs, they don't have any metadata about dependencies. It's just the binaries and the conf files and one tiny little metadata file and so this is that metadata file. It's a release file. So, once again, there's this fake root with a user directory that we're working in. And so the only thing that needs to be in this release file is 2 lines. The distro, SteamOS in this case, and the version of that distro, which is 3.3.1. That's it. So if you have those 2 things, systemd will check to see that the extension passes the compatibility check, like you're actually on the distro that you expect to be on the version of that distro. And if it does, then it goes ahead and applies it as an overlay to the root file system. Okay, so once you have the binaries, you have the conf file, you have this release file, all you do is squash fs it into a .raw file. So this is how you deploy it. So it's kind of like, a container, right? What's the container? It's just a tarball. It's an overlay, right? That's the container. That's an extension image. It's a squash fs overlay. Okay, so here's an example of what would be inside the SSHD extension image. You've got the binary, right? You've got the systemd, service unit files that will start SSHD when you power up the system. You have a file that tells systemd which config file to use, because there are multiple SSHD config files, and you want the read-only one because you're on an immutable file system. And then another thing that SSHD requires is a dedicated user. So you need to have an SSH user and an SSH group, and on a mutable distro, you would user add these things, but guess what? We can't write to the distro. So you do it at build time. You do the user add at build time using Yocto, and this is how you do it. So you're doing user add at build time so that the user is there when the image boots up for the first time. Now, okay, so what about native GDB? Pretty much the same thing. You know, you've got the GDB binary. You've also need the debug symbols. So whatever it is that you're debugging needs to be compiled with debug symbols. They can't be stripped out. You need the source code, and you're off to the races. So this is all easy to do in Yocto. You could do it globally as a feature and say, like, install all the packages with debug symbols and source code. Or you can be more granular and just install debug symbols for the package you want to debug and only install the source for the package you want to debug. Okay, I don't think, all right, I'm just gonna do this. I think this is gonna confuse a lot of people. It's confusing, but I'm gonna drop it on you anyway, and we could talk about it afterwards. So we have an Avocado SDK. So I work on this distro called Avocado Linux. It's a Yocto-based distro. So we built the distro using Yocto. We provide an SDK container image. So you can pull this container image. I believe it's on Docker Hub, one of the registries. So you can pull that container image. You can start it up, and you have a Yocto dev environment without any Yocto. I'll explain how that works in a moment. So here's an example of how you would use that SDK to build a remote GDB system extension. You are now inside the container. You're inside the SDK container, and you can do DNF update, and that will go out to the cloud, and just how you do apt update in Ubuntu or whatever distro you use. There are package feeds out there with packages that you install. We have those package feeds available right now in the cloud for you to install inside of the SDK container. And we support 3 targets that I'll get into, but we can support more. Come talk to us at the Peridio booth if your target is not supported. We want to know what you're working on. So this is how you create the gdbserver extension image inside of the SDK container. It's all command line. So in this case, what you're doing, you're installing gdbserver. This is just a wrapper around DNF. So it's actually calling DNF install and installing the gdbserver package into a staging area. Then you do Avocado build sysext debug tools. This builds the system extension for you, and you're giving it the name debug tools. So it's all that squash FS stuff that Alberto did, the release file with the 2 lines of metadata. That this command is doing that for you. And then you build the image. So right now, the target that I'm using is QEMU. So I'm using an emulator as my target. You can use real hardware as your target. I find it easier to work with emulators. So in the case of QEMU, it's creating the var partition for you. So it's writing the system extensions out to the var partition, and then doing genimage, which is kind of like wick, to create the full QEMU image, so that when you boot into QEMU, the extensions are in varlib. So this is all, and then what you do then is then you launch QEMU with the image that you built, and then you can, systemd starts up GDB, it puts everything in the right place, and in this case, you're starting gdbserver from the command line, but if it had been a service, systemd would have just started it for you. So here you're in the QEMU emulator, you're starting gdbserver, you're pointing it at your app that you compiled with debug symbols. Well, actually, no, this is gdbserver, so you don't need debug symbols on the target. It's all on the host. Okay, so now, flip it around. You're back in the SDK container now. You're not on the target. You're not in QEMU. You're in that place where you have DNF and all the SDK tools. So you need a cross debugger, right, for your target. So you install that cross debugger inside of the container. You only need to do this once. Once it's there, it'll be there every time you start up the container. And then you start debugging. So you call GDB, you point it at the binaries in your sysroot. So you see target, that's QEMU x86-64, but it could be something else, depending on what your target is. And then you point it at the IP address of your target, and you are debugging remotely from the SDK container to the target. All right, so I promised observability. This is observability. bpftrace. So probably not all of you know what eBPF is. I didn't know until a few years ago. It's really, really cool. It's like if you want to debug applications and you just want to insert printfs in different places, create like a histogram of stuff, it's awesome. I use it as a debugging tool. You could do a lot more with it. The thing about eBPF is it requires LLVM. There you are, Kim. So you know all about this. And the only reason I can even do bpftrace or anything with eBPF is because Kem created this meta Clang layer that has all that stuff in there. And so he's got a recipe for bpftrace in there. You can see it's under meta Python, so it's all, I assume it's all Python. But you need kernel support. But these days, all the kernels have eBPF support because it's so cool. And then you've got a few build time dependencies, like BCC is the big one because that requires LLVM. And then you've got Bison, Flex. This is like parser, abstract syntax tree stuff. And then you add the bpftrace package to the image, and you've got bpftrace on board. So, we're doing this right now in Yocto. This is how you add bpftrace to a Yocto image. So I haven't done it yet, but I think we can easily convert this into an extension image, so that if you wanted to just flip bpftrace on, you could enable that extension image and you would have bpftrace. All right, VPN, tail scale. So I haven't found a good layer for tail scale in Yocto yet, but that's okay because this flat car container Linux that I talked about, they use tail scale and they deploy it as a system extension. So they've already proven that it can be done. It's just up to us to do it in Yocto, and I'm confident we'll be able to do that. I've actually been getting a lot of inspiration from flat car container Linux because they have this thing called the system extension bakery, where they have like configuration files that they use to build their system extensions. And so that's exactly the kind of thing we want to do in the Avocado SDK. We want to be able to capture all the work you did to create a system extension so that you could just then play it back and recreate that extension in a reproducible fashion. Yeah, that's just like weird systemd stuff. You want to see that? Okay, this is cool systemd stuff right here. So, like, we know systemd is going to do the merge when you power up, right? It's going to compose everything when you start up. But I found out recently that systemd can actually auto-reload, and so without rebooting or restarting, it can tear down and reassemble the root file system, doing the merges. So, like, these are actual systemd commands right here. So, like, merge does the merge, and then unmerge undoes the merge, and refresh is just unmerge followed by merge. So what we want to do is like a refresh, right? Because that's going to look at what's in varlib and then do whatever is in varlib. And so the way you enable this functionality is by adding one line to the release file, this extension reload manager equals 1, that tells systemd that this extension is reloadable. And then you do this trick in systemd. So systemd uses a lot of symlinks to inform how it's supposed to behave. And so if you've looked at systemd, like you have something called a target. Well, there's various targets. And so a popular target is multi-user, because that's, it's a server, there's multiple users. And so you want to set your system up for that use case. And typically, it's not upholds, it's .wants. So the target wants this service, which is the out-of-memory daemon in this case. So it's always been wants, but now it's upholds. So they added this upholds feature, which means you don't have to restart you don't have to reboot, you don't have to restart systemd. It's actually just checking to see, it's just watching to see if there's changes, and if there's changes, then it just reapplies them. So that is magical and very cool, and I just learned about it. Okay, so there was a meme a while back about, I saw it on LinkedIn, and it was like, if you're using Yocto, or you're entering a world of pain, right? Like this is, that was the meme, and this kind of hurt my feelings. I have to be honest, but they have a point. They have a point. It's we don't make it easy, and the experience could certainly be better, and yeah, so we're trying to make it better. And Justin, who is my collaborator on this project over here, he likes to say, "I build Yocto so you don't have to." So if that message resonates with you, check out Avocado Linux, because if you saw what saw what I did in the SDK, there was no Yocto in there. There was no bitbake, nothing. Like it was a cross compiler and sysroots that were already pre-built. You didn't have to bitbake anything. Okay, so what is Avocado Linux? It's a binary distro, which is like all the mainstream distros, built with Yocto. That is what Avocado Linux is. And like mainstream distros, we provide package feeds in the cloud that you can DNF install. So those package feeds are live now and available for 3 targets. Well, 4 if you count Kimu. It is that SDK that I showed you that is inside of a container image. And it is open source. And I mean that seriously. We operate just like any real open source project. It's a meritocracy. If you have ideas, we want to hear them. If your ideas are good, we will act on them. There's no gatekeeping here. We're trying to build this for the embedded Linux community because we need it. I need it. So yeah, so here are all the blog posts I referenced. So the slides, you can download the slides and go check out any of these blog posts. That crazy upholds trick, so the systemd documentation is very good. It's better than most projects' documentation. But there was nothing in there about upholds. I only found out about it in a video from All Systems Go, which is a very good conference. It is the systemd conference, and they have fantastic videos that you can go and watch. So that's where I learned about that trick that made the auto reload happen. Okay, books. Yeah, so the book is out there. You can get it from Packt. You can get it from Amazon. Oh, wow, there it says you can get the ebook for $9.99. That won't last. Not from Amazon, from Packt. I don't know if I mentioned Chris. Did I mention Chris? All right, I'll mention Chris. So he is the original author. I wanted him to be on the cover because it's weird just to have my face on the cover, because he wrote the first 2 editions, and if you're in embedded Linux, you know who Chris is. Maybe you're just learning who I am. So I did the 3rd and 4th edition. The 4th edition is the new one. That's the one you want. Don't buy any of the others. Get the 4th edition, because all the other stuff is end of life. So you're just wasting your time. So yeah, that's the book. This is how you can connect with me. I'm on GitHub. I'm on Discord. I'm on Blue Sky. And if we have any time left, I'll open it up for questions. Oh, okay. Yeah, there you go. So, I mean, there's got to be questions. That was a lot. That was a lot to process there. Thank you. Anybody? I don't bite. Oh, Deshaun. The mic. I'll give you the mic.
I can kind of talk loud anyway.
Well, let's get you on the recording.
So I'm kind of new to like the concept of like immutable. Well, I've heard of it before, but to get to the question that I want to ask, like, so like for in the context of like embedded systems where like you have to like kind of modify like sort of like device trees or kind of do sort of things to like support different peripherals and things like that. So like how does that sort of thing work when you're kind of like making extensions for that?
So the way it works for ARM is there's a device tree binary blob, whatever you want to call it. That's built using the device tree source. Usually the bootloader like loads that as it's loading the kernel. But maybe there are ways to delay that. DTB overlays used to be a big thing. I don't know if they're still a big thing. So that would be one way to do it. Although, like, I think it's important to look at extension images as a user space thing rather than a kernel thing. Like, I mean, I could understand why you would want it to be a kernel thing, but that is very experimental right now. Let's just put it that way. But I mean, this is good feedback, right? Because if you want it, that means somebody else wants it.
Yeah, so I actually saw Chuck's talk back in December on the capsule images.
Great, right?
Yeah, it was. Yeah. Someone should do that, right? Yeah. And one big caveat he gave was like, look, you can really easily mess things up, right?
Okay, true, but
Do you want to use the mic?
systemd when it messes up now.
Well, so the heart of my question is essentially, contrasting against the capsule images. Do you get any more assurances using the systemd-sysext stuff, or is it maybe just a more ordained path? Like, what does that look like?
Maybe you should ask Chuck. Like, we'll see what Chuck thinks about this.
Well, thank you. I guess we'll go back and forth here, but yes, you can. It's great because you can do whatever you want, and it's awful because you can blow things up easily. So, I mean, like, there's a need when you're doing engineering on embedded devices for, aerospace and all that. You can't deliver with that stuff. So you need to be able to drop it in, get it to work, take it off. Even sysext is too much, right? Like, we're rolling our own init ramfs, sometimes throwing our own init. I have bash scripts running as init, those kinds of things. Building up your own overlayfs is just a hugely versatile thing. So that's why I came up with capsule images, because it solves a big problem. Anytime anybody else wants to, and it also helps with distributed development. So if you have separate teams, you're in a big company, you can have them as long as everybody plays nicely, and then you can have a privileged version that lays over the top, and then an unprivileged version that gets shunted to a specific directory, that kind of thing. Really boils down to the problem you're trying to solve. But yes, you can shoot yourself in the foot easily.
Yeah. You can always get it wrong, right? That's easy.
Yeah.
One more, or are we done? And
Are these topics in your book?
no, this is new. So the answer is no. I did I didn't start working on this until April 1st. Yeah. All right.
This gentleman over here is seriously.
No, I'm giving him the mic. I'm sorry. I know who he is. He's getting the mic.
Why not containers? Seriously.
Because I'm a rebel.